Section 5.4, synthetic division. In the last part, I showed you how to do long division. And that long division, you must use long division when the divisor is not linear. But if the divisor is linear, we can use a different method, which is easier. That method is basically the synthetic division or the collapsed division. So now we know that if the divisor is not linear, we have to use the long division, which is this method basically. However, there is an easier method in this case when it's linear, so we're going to use synthetic division in that case. Synthetic division is basically a shortcut that can be used when the divisor is a binomial in the form of x minus k. Notice how the coefficient of x is equal to 1. So in that case, you will be able to use synthetic division. K here is any real number, and the coefficient is going to be, the coefficient of the divisor is going to be 1. In synthetic division, we only use the coefficients for the division process. We don't use the variables in this case. If we would like to use synthetic division for this division again, which is basically we did previously, we did it right here. How are we going to do it? We're going to do it this way. So we're going to first, my preference is to write the terms on top or the power on top. So I'm going to write x to the second is the highest. So I'm going to say begin with x to the second, and then I'm going to go x, and then I'm going to go to constant here. This is just my preference. You do not need to do that. However, it makes it easy for me to put the correct coefficients under the correct term. So let's say this x term was not there, I would put 0 here. However, I will keep this alignment just to keep track of what's there and what's not there. Next, I will put the coefficients of each of these variables under it. So that is 5x squared, positive 3x, and then the constant is negative 2. I like to separate the constant with dots here, so I know like this is the constant, and to distinguish the remainder that remains here. I'm going to divide this with, now I will set our divisor equals to 0, x plus 1 equals to 0, and solve. So I will get x equals negative 1, which means I will divide with negative 1. So similar in this case, when the coefficient is not 1, yes, you're going to be dividing with fractions sometimes, but it's a doable process. It's not actually very difficult to do. Now we're going to divide. How are we going to start the division? The first step, you're going to bring the first term down. So you're going to say 5, bring it down. Then you're going to multiply 5 times negative 1, and you're going to put the answer under the second coefficient. So you're going to say negative 5 goes here, and then in this case, you're going to add. Don't subtract, you're going to add. So 3 plus negative 5 is negative 2. And you repeat that process. Negative 2 times negative 1 is positive 2, and you're going to put the answer under the last coefficient or last number. So it's going to be positive 2, and then you're going to add, so the answer is 0. This is the remainder, and this is the quotient. The quotient needs its variables back. So we're going to knock the first one out, and we're going to connect these together, which means we have 5x minus 2. So we have 5x minus 2 and times x plus 1, which is basically the divisor, and that is the way you're going to factor that. Here's the quotient, and here's the divisor. And then plus the remainder is 0. So we say f of x, or 5x squared plus 3x minus 2 equals to the quotient times the divisor plus the remainder. So notice that the quotient is 1 degree less than the original function that we're dividing, or the dividend. That is one of the observations that you can make. And notice how when we divide with the divisor, we have to find what the value of x is. and divide by that value. Let's try another one. Here is an example. So I have, in this case, I have x cubed. So I'm going to say x squared, although I don't see it here, but I have to go gradually down, and then x, and then there is a constant here. Now I'm going to put the coefficients under, so 2x cubed, there is no x squared, there is 1x, and then there is a positive 4, divided by x plus 2 equals 0, minus 2, you get x equals negative 2, so you're going to say divided by negative 2. And then we're going to begin the process. We're going to bring the first number down, 2. You're going to multiply and then put the answer here. So x equal to negative 4. And then you're going to add. So 0 plus negative 4 is negative 4. You're going to multiply, put the answer here. So you're going to get negative 4 times negative 2 is 8. 8 plus 1 is 9. I will separate this constant. 9 times negative 2 is negative 18. I'm going to add it here. So negative 18. Negative 18 plus 4 is negative 14. So our remainder is negative 14. And in this case, I will scratch the first one, and then I will connect it this way. So I have 2x squared minus 4x plus 9, and then times x plus 2, and there is a remainder of negative 14. So minus 14 is the remainder, and we can write it over the divisor. Like so. So this is basically the division of this polynomial with that binomial. This is again the quotient. This is the divisor, and this is the remainder. We usually write it over the divisor. So that is basically how you're going to do the synthetic division. Now, I'm going to challenge you, and I'm going to ask you to try to divide this using synthetic division. You're going to have to work with fractions. It's not as bad as it looks. So try it and try to challenge yourself with that one. This is the end of section 5.4. If you have any questions, let me know.